All right, in this podcast, I'm going to show you guys how to find the general solution of an equation where you may have to use an identity to simplify it. So for example, in this equation here, we know that cosine pi plus x is equal to 1/2. Now it's kind of an interesting equation because look at the argument. It's not just x, but it's x plus pi. Now that's a good indicator actually. When your argument has some sort of addition or subtraction going on, look towards your sum and difference identities. So let's see if we can match this up. We have the cosine of pi plus x. So that fits this form right here. So if it does, I can consider alpha as pi and my second angle beta as x. So let's go ahead and apply this formula here, or this identity. So the first thing I want to write out is the cosine of alpha. Cosine of alpha here is actually just pi. And then we have the cosine of beta, which is just x. Then we're going to go ahead and subtract sine of alpha, which is pi, and the sine of beta, which is sine x. Okay, and we want to make this equal to 1/2 because that's the equation. Now cosine of pi. Pi is a special angle on the unit circle, and it's located right there. It is a quadrant angle. The cosine of pi is equal to -1. So this is just simply -1. Cosine of x, can't really do much with that, so I'll leave it as is. Sine of pi, that's interesting. That will just give me 0. So what I'm getting here is 0 times sine x. And this simplifies quite nicely here. 0 times anything gives 0. So what I have here is negative cos x is equal to 1/2. So when you're solving a trig equation, isolate the trig ratio first, or in this case, it's cosine. So get the -1 over to the other side by dividing it or multiplying it, and we get -1/2. So you want to look at all the solutions of x on the unit circle where your x coordinate is -1/2. So let's see where that happens. So I see a -1/2 in quadrant 2. So that's at 2 pi over 3. And I also see another value in quadrant 3 at 4 pi over 3. So within the domain 0 to 2 pi, we do have 4 solutions. But I believe they want you to state a general solution. So when you're stating a general solution, you're using the idea of coterminal angles. So for example, at 2 pi over 3, we're going to have another solution every 3/600, or I should say every 2 pi radians. So the general solution for 2 pi over 3 would just be given as multiplying multiples of 2 pi. And to show multiples of 2 pi, we use the letter k. And then we have the same thing with 4 pi over 3. This solution will repeat itself every 360 degrees. So it occurs here at first, but then it occurs again, and again, and again, over and over again, in the positive and negative direction. So to show that general solution, we have 4 pi over 3 plus multiples, so positive and negative multiples of 2 pi. And to show positive and negative values, we say that k is the member of the integers.